Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video I will introduce to you what is the differential equation. So definition 1.1.1: an equation containing the derivative of one or more unknown function or dependent variable with respect to one or more independent variable is said to be differential equation. So when we talk about differential equation, first thing is we notice that these sentences contain two words. The first keyword is differential. It came from the differentiation. And the second one is equation. So that means in one equation there exists a derivative of one or more unknown function with respect to one or more independent variable. For example, if we have a dependent variable y and independent variable x, hence the derivative is dy over dx. So when we set an equation, that means this derivative of y with respect to x is in the equation. So when we set equation, it must have some form of sign equal. For example, dy dx equal to x. Because in this equation dy dx equal to x, we have the derivative and also we have a dependent variable y and independent variable x, hence this equation is said to be differential equation. A differential equation contains only ordinary derivative of one or more unknown function with respect to single independent variable is said to be an ordinary differential equation. So if this equation contains only ordinary derivative, by mean ordinary derivative is dy dx, hence this equation is said to be ordinary differential equations, or simplified as ODE. A differential equation contains partial derivative of one or more unknown function of two or more independent variables is said to be partial differential equation. So in that equation, let's say we have a partial derivative. For example, dy dx equal to x, and then multiply with the partial derivative of y. So del y over del x, for example. Hence, this equation is said to be partial differential equation, or PDE. The order of DE, differential equation, is the order of highest derivative in the equation. Definition 1.1.2: any function defined on an interval I and possessing at least n derivatives that are continuous on I the order of differential equation is the order of highest derivative in that equation. So when we set the differential equation, we observe the order of highest derivative. In this equation, for example, the order is first order, hence this is first order of PDE. Definition 1.1.2: any function defined on interval I and possessing at least n derivatives that are continuous on I, which when substitute into n order ODE reduced to the equation to identity, said to be solutions of the equation on the interval. Let's see example 1. Determine type and order of the following differential equation. For A, dy dx plus 5y equal to exponent x. So we check, this is the equation where this equation contains the derivative of first order, and this is ordinary derivative. Hence, this is ordinary differential equation and first order. B, we have second derivative of y with respect to x minus dy dx plus 6y. So all the derivative is ordinary derivative, and the highest is second order. So this is ODE, ordinary differential equation, and second order. For C, we have dx over dt plus dy over dx equal to 2x plus y. So all the derivative are ordinary derivative, and the highest order is 1. So this is ODE and first order. For D, we have del u over del y plus del v over del x. So this is partial derivative. Hence, this is partial differential equation, and the highest order is 1. For E, del squared u over del x squared plus del squared u over del y squared equal to 0. So this is the equation contains second order, where second order is the PDE. So this is PDE, partial differential equation, and second order. Concept of solution. Concept of solution. The functional relationship between the independent variable, for example, we have y and sorry. Concept of solution. C. The functional relationship between the independent variable, for example, if we have y, x as the function, so x is the independent variable, y is the dependent variable. So the functional relationship between independent variable x and the dependent variable such as y equal to fx, which satisfy the given differential equation, is called the solution of the differential equation. If this function yx satisfy the given differential equation, then we call this is the solution of differential equation. How we said this function yx satisfies the differential equation? For example, if we have cut. Alright, take one. 1, 2, 3. Concept of solution. The functional relationship between the independent variable and the dependent variable, such as y equal to fx, which satisfies the given differential equation, is called the solution of differential equation. For example, if we have a function y equal to fx, so in this function, x is the independent variable and y is the dependent variable. If this function satisfies the given differential equation, let's say we have a differential equation y prime minus 2y equal to x, and then we are given a function yx. So in order for this function yx to be the solution of this differential equation y prime minus 2y equal to x, hence if we can differentiate yx, so became y prime x, and then we substitute into this equation where yx we multiply with 2 and this is equal to x, and if this function yx satisfy the given differential equation, hence we can call that yx as solution of differential equation. If the solutions of n order ODE contain n arbitrary constant, then the solution is called general solutions of the differential equation. Example, yx equal to a plus b exponent negative 3x, where a and b are arbitrary constant. So if we have n order of ODE, so if we have n order of ODE, for example, second order, and then it contains n arbitrary constant, then the general solution of differential equation must also have the n arbitrary constant. For example, this is two constant a and b. Hence, this solution is called general solution to the second order because we have two constant a and b. If we have first order ODE, then we must have one arbitrary constant. A solution of n order ODE without arbitrary constant is called particular solution. For example, yx equal to 30 plus 70 exponent negative 3x. This constant actually we can find when we substitute the initial value solution, initial value problem. So when we are given the initial value, we can substitute into this equation to find the value of a and b. Example number 2. Show that y equal to a exponent 2x plus b exponent negative x is the solution of y double prime minus y prime minus 2y equal to 0. So in order for this equation y equal to a exponent 2x plus b exponent negative x to be the solution of this differential equation, this function must satisfy the given differential equation. So we look at the differential equation. We have a second order y double prime, we have also first order, and we have a different equation y. So what we need to do is to show that these y are the solution. So we need to differentiate up to second order. So we have y equal to a exponent 2x plus b exponent negative x. Differentiate first time, first order, so we get a exponent 2x multiply the derivative of 2x, which is 2, plus b exponent negative x multiply the derivative of negative x, so negative 1, so we get 2a exponent 2x minus b exponent negative x. And then we differentiate one more time to get second order, so we get 2a exponent 2x multiply 2 minus b exponent negative x multiply minus 1, so we have 4a exponent 2x plus b exponent negative x. Substitute all the derivative with the function y into given differential equation. So we substitute y double prime into this equation, substitute y prime into this one, and substitute y into this one. If we are going to substitute and we find that this is equal to 0, hence we can say that this equation is the solution. So substitute into this equation. So we have y double prime, so 4a exponent 2x plus b exponent negative x minus, in bracket, y prime, 2a exponent 2x minus b exponent negative x minus 2y. So a exponent 2x plus b exponent negative x. So this is called left hand side of the equation. And this equation must satisfy equal to 0. So for left hand side, so we have 4a exponent negative 2x plus b exponent negative x minus 2a minus 2a, so minus 4a, exponent negative 2x, and then so minus and minus, so plus 2b minus and minus, so we have minus plus b exponent negative x minus 2b exponent negative x, so this is equal to 0. So 4a minus 4a 0, 2b and b plus b, 2b minus 2b also 0. Hence, the left hand side equal to 0, while the right hand side is also already 0. So we find that left hand side is equal to 0, left hand side equal to right hand side. Hence, this is the solution. So y is the solution. Prove that prove that y equal to 1 over 16 x to the power of 4 is the solution for dy dx equal to x root of y. Alright, to prove that this y is the solution, we look at the differential equation. So in this differential equation, we have dy over dx. That means you need to find the derivative of this equation. So y equal to 1 over 16 x to the power of 4, hence dy over dx is equal to 4 over 16 x to the power of 3. Substitute into the equation. So we have 4 over 16 or 1 over 4 x to the power of 3 equal to x root of y. Y is 1 over 16 x to the power of 4. So for left hand side, 4 over 16 is 1 over 4 x to the power of 3. Right hand side, this is x. Root of 1 over 16, this is equal to roots of 1 over 16 multiply roots of x to the power of 4. So this is x multiply 1 over 4 multiply x squared. So we get 1 over 4 x cubed. So this is left hand side equal to right hand side, hence y is the solution. So you can do this exercise and find the answer in the given